Hello, I'm Brian. Today I have an old radio to troubleshoot. It is a Zenith All-American 5 AM radio model 504C. Runs off of 117 volts, AC or DC. Back in 1966 is when it was made by the Zenith Corporation. And today we'll take a look at this radio. Well, here's the Zenith All-American 5 radio. I think it has a nice style to it, and at least from the outside here, it's really quite clean. It's very simple. Here, with the Zenith name, and they've got their logo here. This logo is interesting. It's like a shield. The 3 points on top sort of indicating that it's royalty, although this is not a crown, it's more of a shield with those 3 points on top. And you probably can't see it, but if you look at it carefully in person, you can see the stylized Z in the middle of the shield. I've seen these also on the Zenith transoceanic shortwave radios, very nice radios. And this one, of course, has the dial with a little tick mark at the top to show you where you are. It's very simple. This is a simple radio. This is the on, off, and volume control. And let's see. I'll tip it over so you can see the top. It's in good shape. I think it's plastic, just plastic. This side looks okay, as does this side. And if we turn it around on the back, I think it's also looking pretty good. Of course, it has the typical complement of tubes for an All-American 5. The 12BE6, 12BA6, the 12AV6, the 50C5, and the 35WF4. The information on the back, as you can see, it's very well printed on there. And it has the interlock safety system to help prevent people from getting shocked. And so that's what the little radio looks like. And I think in this particular case, since it seems to be in such good shape and all, I think what I'm going to want to do is we'll just plug it in carefully, raising up the AC voltage slowly, and see if she's working. Well, okay, I have it plugged in to the dim bulb device, and also I have the variable AC voltage device. So I'm going to bring up the AC voltage slowly. Let's turn on the radio, and we'll slowly bring up the AC voltage. Right now we're at 30 volts. The bulb's actually looking good, so it doesn't look so far like there's a short in the machine. Up to 80 volts. Things are still looking okay. Up to 95 volts at this point. And all right, we definitely have a hum here. Okay, I'm bringing the voltage way back down. It's only got 23 volts on it right now. Jeepers, that thing has a loud hum when you're up close to the supply voltage. And although the on and off obviously works, the volume doesn't seem to have any impact on the hum at all. And doesn't seem to be trying to bring in any station. So the only thing it's doing is humming, and the more voltage, the louder the hum. Let me shut everything off. Okay, so at least we know that the tubes are conducting the electricity through the radio, because if one of the tubes was burned out, that would cut off the chain, and none of them would work. So it sounds like maybe the filter capacitors or some other capacitors are bad. So I think next we'll remove the back and sort of take a look and see how they have this little Zenith set up. So here the back is removed and we're looking at the insides. This radio is interesting in that if you see the tubes and whatnot, the bottoms of the tubes are pointing in that direction towards the very front of the radio. They've got the chassis flipped like that on the side. I'm more accustomed to seeing them the other way, where the tubes would be oriented going down this way, but this one's set up where they're going that way, and I think that's fine. That should be no problem in terms of the design of it. It's just interesting. And if you recall from the General Electric radio that we looked at in the last video, I had commented about how I liked the setup because it showed the flow of how the signal went through the radio, in contrast to this one. Now, there may be a very good engineering reason for that, and this style may work better than the other one, but in terms of visualizing the flow of the signal through the radio, this one is not like that other one. For example, the power amplifier tube is way over here, the 50C5, and it's not even close to over here where the audio transformer is. This one is the half-wave rectifier, the 35W4, I believe, and this is the first amplifier in the mixer here. And anyway, it just doesn't have the same kind of visual flow as the other one had, which it's just something that I liked anyway. I did notice that the tuning capacitor is very, very smooth. I mean, for a device that is getting close to 60 years old, that's pretty nice. It has a permanent magnet speaker here. Now, what I don't know is when we pull the chassis out, what I don't know is there a printed circuit board? I don't think so, because this looks like it's metal, and it doesn't look like these things are fitted on a printed circuit board, but I won't know. I think there are 3 to 4 nuts that are holding this board, so I'm going to pull those and see if we can get a look at the underside of the chassis, because we already know that the filter capacitors are done for, and we get that loud hum. I can just see the filter capacitor can right here on the side close to the speaker, and that'll be something to take a look at so that we can see how this little friend is going to be nice or not nice in terms of trying to replace some of those parts. So I'll try to pull that chassis out, and then we'll take another look. Well, the chassis came out of the radio easily, and I took the vacuum tubes off of the other side of the chassis, and I flipped this over on a couple of pieces of wood here so we could take a look at it. And one nice thing that I see here is that The can with the filter capacitors in it is really easy to get to and easy to see how it's set up. It has 2 filter capacitors inside this can. One of them is a 20 microfarad capacitor, and the other one is a 60 microfarad capacitor. And the 20 is connected to the green wire coming out here, and the 60 is connected to the red wire, and then the negative side of those electrolytics are both connected together into this black wire for ground. So it's going to be simple. Now, I'm actually going to snip these wires. I'm going to cut the green one, the red one, and the black one, and I'm going to remove this can. Sometimes people like to leave those in just for the visual effect, so it still looks basically like it did. Since this is on the back side of the chassis and not on the front where the tubes are, I'm not that concerned about it. I'm actually going to discard this, and I'm going to put the new capacitors basically in the same spot. And they're going to be smaller, of course, than that large can. And so I'll have those new capacitors in there to do the job of the filtering. This capacitor right here, this waxy, this old capacitor, is a 0.047 microfarad, and it's even got the little label here, outside foil, on the edge. And so it's going to be replaced by one that's much smaller. I'll just clip those leads, and I'm going to solder the new one in. So that'll be that capacitor plus the 2 filter capacitors in the can. Later, I may replace this capacitor, this disc, with a safety style capacitor that would increase the safety of the device. Now over here, this piece of hardware contains some various capacitors and resistors all within this package. It was kind of like an early printed circuit board. You could think of it that way, right? There's some resistors and capacitors in there, and that cuts down on the amount of components that you have on the board. Later, of course, they became the little integrated circuits that we're all familiar with. But this was an early version of that. I'd have no plans to fool with that if I don't have to. I like to leave it just the way it is. So as we move forward here, the next step is going to be to replace those capacitors that I mentioned, and then we will move on from there. So here we have a couple of changes that I've made to the under of the chassis here. You'll notice that the orange can is gone. This is it right here. We'll get back to that in a minute. And this yellow capacitor here is new. It's a modern capacitor, and it replaces this old waxy capacitor right here. And so that's done. Later, I'll have to put the new filter capacitors on this green, red, and black wire. Now, this capacitor can that I took out, as you can see, the red was for 60 microfarads, the green for 20, and the black is common. You can see it right there. So there's 2 electrolytic capacitors in there. And I thought it would be interesting to see what these things will read on the capacitance meter at this point. I mean, we know they're bad because of that terrible hum that we were getting, but I'd like to see what they read. So let me move things around a bit and then we'll take a look. Okay, so here I have my very simple capacitance meter, and I have it set for 200 microfarads, so I figured we would test the 60 microfarads first, and that's going to be black, common, and then red, and that's terrible. 2.6 microfarads. Change the lead to the green wire, which should have been 20 microfarads, and no, we're not getting anywhere near that. Look, when it's set on 20 microfarads, we're only getting like less than 1. Now let's take a look at this waxy. It should be 0.047 microfarads. So, I don't know, let's set it to 2 microfarads and see what we read. Well, we're reading 0.07 basically, and it should be 0.047, and we're reading 0.066. So not terrible, I guess. Maybe a little bit outside of specs. Specs would probably, for a 20% tolerance, it'd probably be in the 0.05 something. But still, it was probably still working at any rate. But I'm glad that it's out of the circuit and replaced with a more modern one. All right, so next I'll put the new electrolytic capacitors in, the 20 microfarad and the 60 microfarad, and then it'll be time to take a look again and see if the hum is still there for some reason, or if we've managed to chase it away. Okay, so made some more progress here. As you can see, I've got the chassis, the speaker mounted back in to the radio case, and I've also put the vacuum tubes back into their sockets. Now, earlier I had said that back here on the other side where that orange can was, that I was going to put the new filter capacitors in the same place, but I changed my mind because we have so much room here in the case. Right here are the 2 new filter capacitors. I glued a little piece of leather onto the case just because I didn't want them directly on the case, and then I glued the capacitors to the piece of leather, so if I or someone else needs to take that out in the future, it won't be difficult. Now, the wires were, let's see, the red wire was plenty long enough to get down to the 60 microfarad capacitor on the positive side, but the green one was short and the black one was short to get over here to the common ground. So I lengthened those by adding a couple of extra pieces of wire, and then used heat shrink on those after they were soldered together. So there we have the new filter capacitors and everything put back in. And if you recall, there was one more new capacitor that I showed you, that yellow one that was on the bottom side. So now what I want to do is put the back on the radio so that we can have the interconnect. Then I'm going to hook it up again to the variable AC voltage supply and the dim bulb tester, and we will see if that terrible hum that it had earlier has dissipated. So let me get it set up and then we'll take a look. Okay, so I put the back on the radio, and now we're ready to plug it in to the dim bulb tester. Let's see. I can move the camera a little bit and show you basically this is how my dim bulb tester looks. I plug it in right there, and then I'll flip it on. It's already on. There we go. And then what I'm going to do is turn on the variable AC voltage supply. I'm going to bring it up, say, to 75. I'm going to keep an eye on the bulb, make sure it doesn't look like I made a mistake and maybe produced a short or something. Turn on the radio. If I see smoke or smell anything that doesn't seem right, or if the bulb starts burning brightly, then I'm going to switch it off very quickly. But so far, so good. So hopefully those vacuum tubes inside are starting to warm up.
Huge cancellation fees. SimpliSafe does things differently. With SimpliSafe, you get award-winning 24/7 professional monitoring around $1 a day without long-term commitments. SimpliSafe earns your trust every day. Right now, get 50% off your custom system at SimpliSafe.com.
So I've got it turned up to about 108 volts or so.
Basically, get out.
This is the month to get a Kia from World Car Kia, and if you have it traded,
knowing my family is protected feels even better.
Coles, all were Democrats. It's amazing to me that the scheduling...
currently the dean at Regent University at the Robertson School.
Okay, well, I'm very pleased. If you recall earlier in the video, when it had the old filter capacitors in it, we just had this terrible hum that we could not hear anything except the hum. Now, by replacing 3 capacitors, we now have what sounds like a pretty good Zenith AM radio here.
Atrial fibrillation, which increases the risk of stroke about 5 times.
Symptoms like irregular heartbeat, heart racing, chest pain, shortness.
Well, there we go. And thank you for spending the time with me to look at this old Zenith radio. I really like this radio now. And I'm going to run it a lot during the next couple of days when I'm around the house. I'll have it turned on, sort of keeping an eye on it, make sure that it continues to work well. And I don't have any reason to believe it won't. So thank you again, and I'll see you on the next video.